Hello students, I am Dr. Tanmoy Vishwash. I welcome you all in my chemistry channel TanmoyChem and Facebook page Chemistry the Mystery of Molecules. Today's topic of discussion is very interesting and unique MCQ. If you know the answer, please write in the comment box along with few words as explanation. If you do not know, let's start. Now what is the major product of these reactions? So first step treated with KH potassium hydride and second step it's a water, means protonation. So what happens in this case? Let's learn the basic concept associated with this problem. So potassium hydride is basic. Why? Because potassium hydride means it's a K plus H minus. Now hydride. Hydride means this hydrogen is carrying 2 electron although it has 1 proton. So you can say it is electron rich, electron excess. That's why it's anionic, means that's why it can act as base. So what it does, it can abstract an acidic proton like this hydrogen. By the way, this carbon is a radiocarbon, means carbon 14. Isotopes have almost similar chemical properties but different physical properties. So, chemically this CH bond is almost equivalent to this CH bond. Next. Cyclopentadiene is acidic due to very high stability of conjugate base. Conjugate base means if you remove this proton, whatever thing remains, means this anion, this is called as conjugate base. By the way, remember one rule, acidity of a substance is dependent on stability of conjugate base. Higher the stability of conjugate base, higher will be the acidity. Now you can say, sir, why not you remove this proton? Because the fate after removal of this proton does not provide that much stable anion like this one. Next, aromaticity. Actually, this carbon ion is aromatic because 6 pi electron. How? 2 pi electron associated with these individual pi bonds or double bonds, and here this negative charge. By the way, negative charge means 1 extra electron, and this carbon already had 1 electron. So, these represent 2 pi electron and this electron remains in the p orbital. So, total here 2 plus 2 plus 2, 6 pi electrons. So, from that perspective you can say, sir, this anion is aromatic. Aromatic means very high resonance and very high delocalization. That means very high stabilization of this carbon ion. Okay. Now, if you says no sir, that's I agree, but I want to do protonation. So, protonation of aromatic carbon ion results scrambling of radiocarbons. Scrambling means distributed, means it distributed all over this. Now, how? I shall explain. Let's look at, as I told, it produces this carbon ion aromatic 6 pi electrons. Now, later on I can draw one resonance, means this will come, it will open. By the way, student, I suggest everyone please practice drawing resonance in home. Many students struggles. Now, right now look at carbon ion position is this, you can draw another carbon ion where further delocalization is possible, means this can come here, these will go there. So, negative charge here, this is right now radiocarbon. So, what message I want to give you? Because of resonance or delocalization, this carbon ion is distributed. Now, if you think, sir, I want to do protonation of this one, so you will get this. Now, if you do protonation of this one, you will get this carbon ion, means the radiocarbon here, proton added here. If you say, sir, I want to protonate here, then what you get? This case, your radiocarbon here, this is. Now, if you look at very closely, that's a radiocarbon at here, same where protonation is done. Next, you may think like that ortho type, but it is not. Next carbon here, next with respect to the proton here, even second next this. By the way, these and this position same, doesn't matter. This and this position same, does not matter, and here already. So, what do I mean? If you check the distribution, you can see that some molecule have carbon ion here, some has here and here same, some has here and here. So, if you think overall perspective, this radiocarbon was initially confined at this position, right now distributed all 5 positions. So, this is called scrambling. So, if you check, you will not get the protonated species by water that radiocarbon is here. No, it could be here, it could be here, it could be here. So, A, B, C all means option D. Okay. So, this is a very interesting concept. I believe you have learned. See you in my next video. Bye bye.